First up, an angle inscribed in a semicircle must be a right angle. Inscribed shapes to cover with you today. The first one says that an angle inscribed in a semicircle must also be a right angle, must always be a right angle. So draw a circle. A semicircle is what part of a circle? Half. So let's draw a diameter to cut the circle in half. I'll label the diameter as AB. I'm going to inscribe an angle that opens up to that semicircle. So let's put another point about right up here. And I know it's an inscribed angle because that point has to be on the circle. How many degrees does angle C open up to? I follow along these dotted lines. How many degrees does angle C open up to? 180, Tristan. This is a semicircle. A semicircle is always 180 degrees. So if the inscribed angle opens up to 180 degrees, what's this angle measure have to be? Why? Half of it. Half of 180 is always 90 degrees. Any angle that opens up to 180 degrees has to be half that, which is 9. Half of 180 is 9. What I was kind of trying to draw is this. How many degrees is arc BC? This green arc is how many degrees? What do you say, Kara? This BC part here, how many degrees is that semicircle? 180. Since the inscribed angle at D is opening up to that same semicircle, it's worth half of the 180, which is always 90. No matter where you put that point on the other part of the circle, the angle measure is always 90 because that angle, as I move it back and forth, is always opening up to the same semicircle. Nothing to it, check. We had one more. Second property about inscribed shapes I'd like to talk with you about today says this: the opposite angles in an inscribed quadrilateral must always be supplementary. Supplementary is that they have to add to 180 degrees. Definition of supplementary angles is a pair of angles, two angles that have to add up to make 180 degrees. So what would be supplementary with 120 degrees? What plus 120 makes 180? What do you say, Tom? 60. 60 and then 120 added together make 180. What's supplementary with 110 degrees? You got 70 by doing what? Subtracting from what? What's left over? If one of them's 110 from 180. 180 minus 110 made the 70 number. So this statement says that the opposite angles in an inscribed quadrilateral have to fit that supplementary definition we just talked about. Let's draw an inscribed quadrilateral. Draw a circle. Since we're going to inscribe a quadrilateral, it has to have 4 points on the circle. Quadrilateral has 4 corners, 4 angles. I connect the 4 points I drew. I make what is called an inscribed quadrilateral. Inscribed quadrilateral is where all 4 points, all 4 corners of the shape are on the circle. So let's give these some names here. Let's go clockwise. WX lines. So opposite angles, what does that mean? Destiny, what's opposite angle? On the other side. So opposite angle Y. These 2 angles have to make 180 degrees added together. So like I said, if this one's 85, what does W have to be? No, they gotta make 180.
Oh.
180 minus 85 is actually just 90. Why is that? Let's run through this quick explanation here. I'm going to work with one of the pairs. Let's try doing this for one of the pairs. How about Z and X? These are inscribed angles. So let's open them up to see what arc they cut off from the circle. I'm going to open up angle Z. Follow along the sides. Where does it cut off on the circle? WXY. So angle Z equals 1/2 of the measure of arc WXY. Since it's an inscribed angle, it opens up to half of the arc measure it creates. Okay, we open up Z. Let's open up the angle opposite Z. Let's open up angle X. I follow along the sides of angle X. What arc do I create, Taya? Where do I land on the circle? Using Y. Oops, that's not going to. So angle X opens up to the other arc on the left side of the circle. Since it's an inscribed angle, it opens up to half the arc it creates. Now when I add these together, it should be equal to 180. So let's add angle Z and angle X. If I add the 2 angles on the left, that would also be the same as adding the 2 arcs together on the right. These 2 things added together are equal to these 2 things added together. I can write the equation that I put up on the board. We each have a common factor of 1/2 for us to factor out. And here's the magic. Here's a little trick. WXY is the right part in red. WZY is the left part in red. If I add these 2 arcs together, how many degrees do I have? What's it? Why? I don't see 360 anywhere up here. Where are you getting 360 from? I mean, it's not necessarily half of the circle, but I see what you're saying. I don't necessarily know that this is a semicircle. But in general, isn't it just a full circle, no matter what? WXY and WZY form the entire circle. It's two arcs that put together make the whole thing, all 360 degrees worth. I don't want all 360, I just want half of it. So half of 360 makes your name. Any two opposite angles in an inscribed quadrilateral add up to make 180 degrees. That's what I've just proven there. Using inscribed angles. Outstanding. So